Thank you for attending this webinar on how to choose a temperature surveillance system. So, where do we start? So when we look at electrical systems, I mean, if you look at this panel here, this electrical has many points of potential failure. Each connection or internal component has the potential of failing and shutting down or catastrophically damaging your equipment. So really you need to ask yourself the following questions. Which of these connections that you can see here are the most critical? Which has the highest potential of failure? With limited inspection points, where would you place your temperature monitoring system? And what is your cost per measurement point? So again, looking at this, which one of these can you choose? If you have limited measurements, where would you put them? It's a question that really isn't easy to answer if there is an answer at all. So there are different types of temperature surveillance systems available to you today, and we're going to sort of go over a couple. I'm going to look at hardwired single point measurement systems. We'll look at some hardwired infrared camera or infrared sensors or pyrometers, and also then we'll look at ambient temperature monitoring systems. So we'll review these in turn. So first and foremost, if we look at a hardwired single point monitoring system, these require the following. You're going to need a data hub for collection, so where you're going to plug all of the temperature measurements back into. You're going to need to provide a power source or a power supply for this data hub. You're going to need to provide communications, such as maybe it will be plugged into the intranet, it might have a GSM or Wi-Fi connection, so all of these will need providing. And then you're going to have to run a connection or a cable to every single connection you want to measure. So if you look at this panel here again, this will show that if you wanted to measure each one of these, it requires 15 fixed hardwire points to effectively cover the whole panel. And again, some of these are moving connections, so again that causes a whole bunch of other issues. So hardwire systems have a place in the market space, but they are expensive and not very easy to install. So the next system we're going to look at briefly is the infrared camera or sensor systems, and these require the following. The camera or the pyrometers or infrared sensors, whatever you're using, will require a hub or a data collection point to plug everything back into. You're going to need to provide power, and you're also going to need to provide communications, again either from plugged into the intranet through direct Wi-Fi. Some of the camera systems have direct Wi-Fi and you have to just provide power. Others have to go in directly into your intranet and you have to cable those up. So there's a lot of cabling that he's doing. Now the only issue really with the cameras or sensors is that they're limited, very similar to an infrared camera, by the field of view. And the field of view means exactly, it's like a measurement cone that the camera or the sensor can see. So again, they can only measure what they can see, and field of view is affected greatly by the panel distance to internal targets, and also you've got some internal connections or internal things. So if you look at this drawing here, you can see that the phase dividers here again cause a physical barrier to the camera or the sensor looking at what it can see. So if we do, in this example, if the sensor had a 45-degree field of view and the panel distance to target was 10 inches, then doing a rudimentary field of view calculation, the fixed area on that sensor will be an 8.3 by 8.3 inch square. So then if you look at that on this panel alone, you would need 9 fixed cameras, sensors or pyrometers to measure all of the connections effectively. And again, that's 9 cameras or pyrometers, 9 connections, 9 cables, a data hub, etc. So again, becomes very expensive very quickly. I see infrared, etc., having more of a benefit on the measurement of process more than inbuilt in electrical panels, because they become quite expensive. However, there are some very critical panels with very small temperature areas we have to measure, and those work very well on this type of system. So the final one I'm going to look at is the ambient temperature monitoring system. So failing connections produce heat. That's what we know that, and this heat will raise the local temperature around the connection through standard heat transfer through convection, conduction and radiation. So the internal ambient of the panel will rise. So this heat transfer will raise the internal ambient of the enclosed panel, and the rise in internal ambient temperature can be used as an alarm parameter. They're very simple, it doesn't matter how many connections there are, just one connection can raise the temperature of a panel relatively quickly. Although they're smaller, raises in temperature, we can set the alarm parameters quite tight to pick up these small ambient rises. So, what we have here is a delta T alert system, and these require the following: one delta T alert sensor. Just one sensor does the whole panel. Yeah. The power supply from batteries. Now the batteries are we have two versions: a batteried and powered version. The battery version has 3 AA batteries. Will have a lifespan of approximately 18 to 24 months, and this is a 24/7 monitoring system. So you're going to get almost 2 years, depending on how many hard measurements you make a day, out of a set of batteries, which is significant. Wireless communications are wireless, so it's networked into a client system. So we have gateways that are plugged into the local area network, and that basically gathers the data back to one PC from each of these sensors. And each sensor and gateway has a range of 300 feet line of sight. So again, we typically use one gateway in a switch room, maybe 10, 15, 20 delta T sensors, although that you can put over 250 delta T sensors on one gateway, but the limitations are always on range or line of sight. So if you look at ambient temperature monitoring systems, one of the things we started to do, so once we're monitoring the ambient, a really quick thing we can do is actually add maintenance inspection windows to allow access for clients. So again, if the alarm goes off on an increase in ambient, you can turn up, look through your infrared windows or your maintenance inspection windows and see what's going on inside of there. So looking at this type of panel, this would probably have 2 Cat 12 infrared windows, 1 delta T system, and now I have a complete monitoring system. This really enables me to do a number of things. By looking through the maintenance inspection windows, I can determine which connection or component is failing, what the actual temperature of the failing connection or component is, and if I need to do anything on the remedial action, I can then either see maybe I can reduce the load to bring the temperatures more back into line and to try and stretch it out to the next maintenance shutdown. But whatever, I've got a set of eyes and an engineer looking exactly what's on there. So if I can't get it within the acceptable limits, I can then basically arrange the spares, the shutdown, the maintenance engineers, the repair team, etc. can all be sorted out, and I know exactly what's going on. Another thing about doing this, this is the results of a recent study by Emerson saying that the effect of regular skilled preventative maintenance and remote monitoring of critical systems have a really significant effect on the mean time between failure. And it showed the following results. That if I was to do, with a delta T system doing, let's say, 4 visits a year, I can increase the MTBF on this system by 51 times, which is very, very significant, especially in the critical power world. So I have now an online monitoring system monitoring the local ambient, irrespective of how many connections are in there. If one of those goes rogue, it's going to increase that ambient. When the ambient increases, I can do the inspection, but I'm going to do 4 inspections a year, because using the maintenance inspection window, I have ease of access, and these inspections take minutes, literally minutes. So the benefits of using the maintenance inspection window and ambient temperature monitoring system provides the following benefits. We remove high-risk behaviours associated with open panel energised inspections of electrical assets. We conduct fully loaded inspections, which is really when we want to do them. We can access inaccessible equipment, so irrespective of how high the HRC level is, it doesn't matter, because the panel remains enclosed and guarded, and I'm not exposing myself to energized work. So I'm literally looking through a maintenance inspection window, taking all of my readings and moving on. The inspections are much faster because there's no PPE or panel removal. Less manpower is required, again just one person with the measurement equipment doing his job. Lower personal protection equipment levels because again enclosed and guarded. We increase the inspection frequencies because we've made it much easier to do it. We have an increased return on investment on our critical asset surveillance technologies, equipment and training. And we have a significant increase on the MTBF of electrical systems. Summarise. Delta T Alert ambient temperature monitoring system benefits are because they're easy installation and setup. We literally just drill one hole, insert the device in there, and it's measuring away. It takes literally minutes to install. No cabling required. Wireless communication between sensors and network gateways. Far less expensive than single point measurement. Systems as one sensor monitors all connections within the panel. Yeah, and not affected by field of view limitations of camera and pyrometer systems. So it's a significantly less money to install and very, very effective. So thank you very much for taking the time to listen to this webinar on temperature measurement. If you'd like more information on the Delta T Alert systems, you can visit our website at www.iris.com or email us at info@iris.com with any questions and we'll get straight back to you. Thank you, stay safe and have a great day.